Hi friends, in this lecture what we'll try to basically look at is understand the concept of internal forces and then look at what are the different type of stresses that a body can have. Now let us suppose that this is a body and this is F1, this is F2 and this is F3 forces, and under this forces this body is in equilibrium. Now let us cut this body in two halves and the shaded region, we draw it here. The body is subjected to forces F1 and F3. Now as this body is in equilibrium, we know that this body should also be in equilibrium, and to make this body into equilibrium, this F1 and F3, the forces of F1 and F3 has to be balanced by some sort of a force. And these forces are basically what are called the internal forces. And these internal forces are basically given by this rest portion of the body to this body. So these internal forces act on the body, and it is what that restores equilibrium. So essentially, when there are external forces acting on the body, there will be internal forces developed all over the body, right? And this comes basically from the concept of equilibrium, that if a whole body is in equilibrium, then any part of the body will also be in equilibrium. Now what we'll look at basically is understanding the concept of stress. For example, if you have a rod like this, and if we decide to pull the rod by a force F, this rod, suppose, has a cross section of A, right? Then stress, that is force per unit area, is defined as stress. So stress is defined as force per unit area. The force is normally has an unit of Newton and area has a unit of meter square. That are the SI units, and basically therefore stress will have a unit of Newton per meter square or Pascal, right? Now what are the different types of stresses that a body can have? Stresses are basically of two types. Stresses are basically of two types. Number one, you have the normal stresses, and number two, you have the shear stresses. Now in normal stress, what basically the concept of normal stress is, the force is acting perpendicular to the cross section, right? For example, if I take the example of the rod again and place it here, or some kind of a square rod, and I decide to pull it by a force F and F. Now this force F is acting perpendicular to the cross-sectional area of the rod, right? And this type of stress, and a stress will develop over this region of the cross-section, and this stress is nothing but force per unit area. And this type of stresses are essentially what are called the normal stresses. Now this normal stress will be of two types essentially. One is called the tensile stress, when the stress will tend to elongate the body, and the other one is called the compressive stress, when the stress will try to shorten the body. So normal stress will be of two types, tensile and compressive. So sigma is equal to F by A. Now let us understand the concept of shear stress or tangential stress. Now if the force acts tangential to the cross-sectional area, right, then the stress developed is called the shear stress. For example, I have this box and it is rooted, suppose, to a table, right? Now if I apply a force along the tangential to the cross section, this force is applied tangential to the cross sectional area A, then there will be some kind of a relative movement of this plane, right? And this type of stresses, when they occur, is called shear stress. So the shear stress is denoted by tau and is essentially equal to F by A. Now there are some kind of derivatives of this normal and shear stress, and essentially they are called bearing stress and torsion stress. Now bearing stress is nothing but the derivative of normal stress. For example, let us try to understand bearing stress by this simple example. I have this duster with me and I have this pen, right? And this pen has a cross-sectional area of this, and this duster has a cross-sectional area of this. Suppose I apply a force such that I want to press this pen against the duster. Then this force that I am applying is applied not to the whole cross-sectional area of the duster, but to the cross-sectional area that is common between the pen and duster. And this type of stresses, when they occur, are called bearing stresses. So essentially bearing stress is like this. I have this as my bigger cross-sectional area A1 and this as my smaller cross-sectional area A2, or the common cross-sectional area. And I decide to apply a force through A2. So essentially sigma B will be equal to F by A. And most often than not, we see that the bearing stresses are much more higher than normal stress, obviously, because it is acting over a lesser cross-sectional area. Now, after this thing, what we're going to do is basically understand the whole concept of torsion stress. Torsion stress, suppose I have this whiteboard with me, and I decide to fix this pen, right? And decide to fix this pen, that is the base of the pen is rooted to the whiteboard. And I decide to twist this pen like this. And after a point will come when a large force or a large torque, if I apply, then essentially this plane, right? For example, this is like this. I have this pen rooted to this board of mine and I apply it a torque, right? Then what happens is that this plane will move with the application of torque. This plane will move like this. So essentially there will be this displacement of theta when torque is applied, right? And this is essentially nothing but a shear stress, but a derivative of shear stress rather. So I think I've covered all the types of stresses that normally occur on the structure, as well as I've dealt with the concept of internal forces and what are stresses. And this is all for this lecture. Thanks a lot.